Hey, so let's talk a little bit about how iximiuz labs can be used as OpenScienceLabs for a high-performance compute example. So what are we looking at here on the right side? I've got a paper. This is a paper in solar physics. So we see here is an author, and this is a journal article. And to this journal article, there is actually a DOI, a document identifier, and there is a paper companion. That means there's data and scripts that you can use to reproduce what was done in this paper. For example, if you want to use it for your own research, you're just curious, or you want to verify it, maybe if you're a reviewer. So what's happening here is maybe you see that it's 10.9 gigs of data. These are HDF5 data. That's hierarchical data format that is very common in this discipline of science. And um, and it's published here together with the original publication. So on the right side now, we have the dashboard open, my dashboard. I'm an instructor level um, member, or have this authorship feature turned on. And you can see that I have started playgrounds. So if I wanted to create content on the platform, first thing that I do is I figure out, do I want to create, what kind of content is going to be? Is it a tutorial? Is it a course? Is it a challenge? In this case, we're going to go for tutorials. They are simpler than courses. Courses are, more to write, more structure, sub chapters and sub headlines, different playgrounds in there. And you can go into my content and you see, oh, I've already created something for Open Science here, a tutorial. So typically what you do now is you create a new tutorial and you fill this out and you get a slug. So this one cannot be changed, and you fill something out like my absolutely awesome tutorial on how to reproduce my paper. And then you can, so, and this could be literally anything. You can choose a playground for the tutorial as well. However, all these settings, apart from the URL friendly name here, is something we can change. So now we can create the tutorial, and now we have an access to a CLI tool. Now, this CLI is essentially a way to interact with this entire playground on the server side. The first thing we're going to use it for is to get the files that control the content down into our own laptop, so that we can, for example, put it into Git. Now, you don't have to use Git for this, but it's highly recommended because yeah, version control, right? So the other thing, you can do a lot more with this labctl thing. We've done this for now. And then I have cloned it here on the left side into my VS Code. I have these Pokeballs already open. And now I'm actually going to go over there. I've already got some content in there. And you can see here on the left side, you will get Markdown. This Markdown is like opinionated Markdown. So there is a sample tutorial that teaches you the dialects here. We can choose what we have as a base playground. That's the first important choice that we have to make. The others is like the cover image, okay? So in order to figure out what we want as a base playground, you may want to check over to playgrounds, because this is where you find a good list of what you might want to base it on. In this case, I've picked Docker, but we could have also picked Ubuntu, or pretty much whatever you would like. There is Arch. There's an older Ubuntu here, something with Python pre-installed, Node, but also Alpine, Debian, Fedora, Rocky, Alma, and Arch, which maybe if you're more familiar in the supercomputing world, you might like a Rocky, for example. In any case, so once you've picked whatever you like, so the Docker is based on Ubuntu here, what we can then do is we can prepare the environment. So what does it mean? So we have up to this line 45 here, where we have some dashes. We can give instructions of what happens behind the scenes. So in this case, I want to have an update. Wow. And I want to install some stuff like Fuse, curl, Python, ImageMagick, and then some very custom tool that's going to come in very handy. And what happens now if I press Start Playground here on the live side of things is that it does these tasks. So it's while it's warming up, we can actually look at the task debugger And here, this is exactly what you see. This is task one, in a task one, because I'm creative. And now it's going to wait a little bit until it actually does this. So now we have, and I'm trying to fit 3 vertical windows here, so real estate is a bit small. So what I'm going to do now is that the playground is warm, so I have a live Linux here, so we can do, see that system is doing something. There was actually WebSockets being linked into the browser here. And here on the side, I have my source code. So this controls um, either what's going on behind the scenes, so certain challenges, for example, and installation procedures, as well as, of course, what exactly is in the markdown. And I'm gonna now activate the pushing. So now everything that I'm going to write in my, there you see, that I'm going to write is going to be live, put into action on the actual lab playground. So this is a CDN. Um, so I put here a task. So tasks mean that I could, for example, watch for something being cloned. I did this after I started the playground, so currently it's not defined. So in this case, what we want to do is we want to use the rclone utility, which we've previously installed, to mount the data, those 10.6 gigs from Zenodo, and then we want to reproduce the paper, which is going to be some Python scripting using HDF5 libraries. So in this case, I'm going to copy this. So this is, you should see, the same as here. Now, if I press save, you see it just changed the content. So this is live as long as I have the forwarding on. So I copy it. It depends a little bit on your key bindings. I'm on a Mac, as you may see. So, so that was so I've configured the rclone config. Now I'm going to mount it. Now this mount configuration is something that most users probably don't necessarily want to understand in detail. And that's exactly what we're doing. So we're just copy pasting shit. Excuse my language. And now, just to test if what we just did actually mount this record, so of this exact DOI, so if we remind ourselves, we went to Zenodo and got the DOI here somewhere, where's the DOI? Here. 105281 blah blah blah, and then the actual record type 105281 and then something with 8. Well, we're going to see in a second if it's the right one. We're copy pasting again. So I've written a little test here just to check, iterate through those remote mounts if we can see it. Python 3 was previously installed in the warm-up task, so I should have it. And now what I've done is, so here basically it's like files found, and it goes through those Magnetosphere HDF5 files that you found, and they are remotely accessible. So why is this cool? So we as the admins or the paper authors made this available, this rclone tool, so that was already pointing to our record. And now within a live Linux environment here, this Ubuntu with Docker installed on it, we have the data available to ourselves, and we can use Python over it. Oh, this is remotely mounted. It's 10 gigs, so it's not going to perform particularly well. This is why we used some caching. So at least that if you've used the data once with your script, it will cache it until it runs out of memory in the lab itself. So this is the desired output that we should be getting, and we can compare, and it's going to be the same. And now, in order to use this specific paper, we need to install very specific Python libraries from pip. Those are published by APL in this case. They were in the paper, specified what exactly you need to actually download. So this Python situation is going to take a while. And this is also important that as the paper author, if I wrote the Python myself, I put it on PyPy, then I'm also the one that should be most knowledgeable giving someone else the exact pip3 install command. And while we're waiting for this plot here to finish, which is not fast because we're currently loading 10 gigs over the wire, so the cache is completely cold at the moment. So don't expect this the first time to be highly performant. We can look at some other functionality. We can switch here to the IDE, which is a VS Code server. So this is not a fully fledged VS Code, but so I don't think you can do the extensions, for example, but you have your other typical functionality. Other things you can do, you can open terminals in here, you can open more terminals. Now this is a, let's say, a bit more boring playground, but you can actually configure playgrounds to be constructed out of more than one VM in case that's interesting, and you can also pre-configure those terminals differently. And in this case, we don't need to, this is the one that's still plotting. The other things we can do is we can, for example, expose ports. So if we wanted to work with Jupyter, for example, we could have Jupyter running and then expose the Jupyter port here. And we can also share a web terminal session. So I could now give myself a public link and then share with you this public link and collaborate in the web terminal as long as the session is open. This could be really useful for debugging sessions, and I've totally used it for debugging. And oh, there's our picture. It's finished, maybe. Yes, it's loading. So we've just plotted here. All right, let's make it bigger. The ring current, and now we could compare it with the original publication. That is actually the same one. So this here, figure 5. And the reason why we wanted to have these labs is that we could now link into Zenodo, not just the data, but we could also link a link to where this tutorial is actually listed, and so people can actually reproduce it. Thanks. Enjoy.